So we have this 876 of LeetCode, middle of the linked list, and the question states that given the head of a singly linked list, return the middle node of the linked list. If there are two middle node, return the second middle node. Now, two middle node only for the even case. If let's say we have two nodes, then we need to return the second node of it. Now, the first thing that we would do, now looking at the constraint again, the constraint is really low from 1 to 100, so we can use an on or 2 times on operation or even on square operation. Will not have any problem. Now let's say the first thing that we're going to check is for even and odd case, right? For even and odd case, even case, let's say we have linked list like this, and for odd case we have three nodes. Now here the number of node is 2 and here the number of node is 3. Now the middle of the linked list would be this one. This should be our answer, right? And for the odd case, this will be our answer. Simply what we can do is we'll initialize an integer as mid and take the number of node and divide it by 2 for every single time. Even if for the even case and the odd case, we'll get an answer. Let's say for even case we have 2, so 2 divided by 2 is 1. So from the head we'll move once and we'll have the middle of the linked list. Similarly for the odd case we have 3, so 3 divided by 2 is 1.5, and for integer value we'll have 1 as answer. From the head we'll move once and we'll have our answer. So clearly the first thing we would do is we'll create a function. That function will count the number of nodes and return it to a main function, number of nodes, right? And in the main function we'll define a mid variable and assign it to the number of nodes divided by 2, and we'll run a while loop, right? We'll run a while loop, and in the while loop we'll start from the head and go to the middle of the linked list and return the middle of the linked list, right? So counting in a linked list is very simple. Let's say for example we have this linked list and null. Simply we will write while, this is our head, let's say, and we won't change a head of a linked list by any case. So what we will write is first the type is not given, so let's say tree node or linked list star temp is equal to head. We assigned temp to head. Now temp is pointing here. Now simply we'll write temp not equal to null. While temp is not equal to null, we'll take a variable, let's say counter, counter, set it to 0, and we'll do counter plus plus, and every single time we'll shift the temp to the next node. How we will do it? Temp is equal to temp next, and by this single for loop, this single for loop we will be able to iterate over the linked list once, and we'll have the number of nodes in a linked list, right? Now we at the end we will return the number of nodes side, so we'll write return cnt. Now it will return it to the main function. Now in the main function what we are going to do is define a mid variable and we'll say cnt divided by 2, right? So we have our mid. Now here again linked list will define another linked list type variable, so that we'll start from the head and move to the middle of the linked list, and once we are at the middle of the linked list we'll simply return it, right? So linked list star, let's say iterator is equal to head, right? Iterator equals to head, while iterator we should write, okay, we have the mid, right? So we'll simply write while mid minus minus, right? Minus minus, and here we will move the iterator. Here we will move the iterator, iterator is equal to iterator dot next. So what actually happened is that we had this linked list null, and by performing this operation we actually got count value as 3, right? Simply we iterated, moved the temp from the first node to the last till the null, and we counted the number of node in a linked list. Now we also have the mid value to be 1 and assigned the iterator at the head. So we wrote while mid minus minus. So mid minus minus is, mid is 1 and mid minus minus is a postfix operator. So first mid is calculated and loop is run, then the mid value is changed to 0. So first this will run, while 1 will run, then it will be while 0 and the loop will break, right? This will run. So while mid minus minus, iterator equals to iterator dot next. So iterator is moved from here to here, and this is actually the middle of the linked list. And for the next time when the mid comes, the mid value is 0 and 0 minus minus, so minus 1. The mid, while 0 will get executed. So while 0 is actually null, so it will not run. So we'll get out of the while loop. Now at the end we'll simply return the iterator, right? Iterator, as this is our middle of the linked list, and this will also work for the even case also, right? If we have a even case, we'll simply return this node. The code will remain exactly the same. Now we'll look at the code and calculate the time complexity and space complexity of it. Now if you see, we created two functions here. This is the first function, sorry, this is the first function, and this is the main function, right? This function, what it does is calculates the number of nodes. So once we are iterating over the linked list till we hit null, so simply this takes an time complexity of on, right? And this operation where we go to the middle of the linked list, so if the number of node is n, we actually have to iterate for n by 2. So this takes, this is the while loop, right? So this takes a time complexity of o n by 2, right? And all the other operations are constant, so for very large value of n, we can simply ignore it. Now the total time complexity is on plus o n by 2, and this is the time complexity. And for the space complexity, we haven't taken any extra space. If we exclude all these constants, all these mid variables and counter variables, we haven't taken any extra space, so we can simply say we took O1 space complexity, and for the time complexity we have On plus On by 2. Now there is another thing I need to point out. Now when we are iterating over a linked list, we are simply writing while temp, we are assigning initially, let's say this is the linked list, right? This is the sort linked list we have, and this is the head, and we assign temp as this one, right? Now what we are saying is that while temp not equal to null, so temp will go to the first node, then temp will go to the second and go to the third, and in the fourth iteration it will break. So it actually goes over to all the nodes. Now temp not equal to null is one way of saying it, and there is a different way of writing it, the same thing. We can simply write while temp, and we change the value inside it, move the temp to the next node as temp dot next. Now what actually happens is that temp, while temp will be at the first node would have something, right? Some value. Then will temp go to the second node would also have some value, so while some value would still iterate. Then temp node will go to third node, so while third node would have some value. Then when the temp goes to null, we'll have while null. Now while null is internally treated as while 0. Now while 0 is loop is broken, so either we can write temp not equal to null, or there is a smart way of writing while temp. Both works the same. So we had this time and space complexity, and we can actually replace this over here and here, right?